Live.
Yes, we are live. Okay, so again, thank you to everyone who just competed in chemistry and biology and who listened to all of our lectures throughout today. We're now going to kick off the mathematics speaker panel, where we'll journey into actuarial mathematics, the relationship between algebra and geometry, the intersection between probabilistic combinatorics and mathematical theater, the connection between origami and math, and some questions about place value. To start off, we have the amazing Dr. Corina Constantinescu, a mathematics professor and the director of the Institute for Financial and Actuarial Mathematics at the University of Liverpool, who's going to take us on a journey through actuarial mathematics. Dr. Constantinescu worked as an actuary and led the life insurance department of one of the first private Romanian insurance companies. Dr. Constantinescu is actually joining us very close to midnight her time. So thank you so much for coming at such a late time to help us inspire the next generation of mathematicians. Without further ado, Dr. Constantinescu, please take it away.
Thank you. Well, thank you very much for the invitation, and I have to congratulate the organizers for this exceptional event that seems to go extremely well so far. And indeed, the energy is quite amazing to see. So as Diana said, I'm going to take you through a small journey in actuarial science and how I see actuarial science, and to answer a few questions like, why did I become a mathematician? For me, it was a way to make friends, and it's still a way to make friends because I love to work with others, and mathematical problems are the right kind of challenge and that generate discussions and very, very nice debates. And mathematics has a language of its own that it's very easy to speak, no matter where you are from. And that's always very inspiring. And I believe for everyone who loves mathematics that you know that finding the right solution, there is no kind of better reward than solving a problem and finding a solution. Now, why actuarial mathematics? Why an actuary? An actuary, if you work in industry, it's a business professional who would analyze the financial consequences of risk. So to do that, you would use mathematics and statistics and some financial theory to study uncertain future events. It's mostly used in insurance and pension programs, but it becomes more common to be used in other fields. And I am convinced that more and more risk managers will be needed in various areas outside insurance. Now, there are some societies that will have professional exams from which you would become a professional actuary. And one of them is the Institute and Faculty of Actuaries in the UK, and the other one is the Society of Actuaries in the US. Here in the picture is the magazine of the Institute and Faculty of Actuaries, this edition, August 2020. I'm proudly holding it because one of our research has been featured in it. And this is the first one I want to talk to you about. So insurance, for those of you that don't know, have a few branches. I will only mention 3 of them today. One of them being life insurance. So life insurance refers to pricing in the event of death, and it's related to pensions, and it's related to all sorts of annuities if you survive or if you die in an uncertain event. Now, usually families are insured, but never is considered that 2 spouses are in any way dependent on each other. Although there is a documented syndrome, the so-called broken heart syndrome, that occurs as a heart condition in a stressful or extreme situation, for instance, in the loss of a spouse. Now, in developed countries, Western countries, it's been documented as existing, and it manifests within the first year of what's called bereavement. So the first year after your spouse passed away, you are more likely, you are so affected by this that you are very likely to pass away as well. But as a positive of it, after a year, if you survive that year with the help of your family and friends, you would be recovering and having the same life expectation as anyone in your age group. We were wondering if the same will happen for African countries, where the community structures are different, where you tend to live with your family and with your close and not so close family. And the social structures, the fabric of the social structure is very, very different. And in this project that I work with one of my colleagues, Olivier, that's originally from Cameroon, and one of our students, Kira, that's from Liverpool, we have looked at Ghana in particular to see if indeed such a broken heart syndrome is prevalent there. And our observation was that, yes, it is, but it's not the same first year effect. It has a delayed effect, which probably is explained by longer funerals. The whole process of grieving has a very different format. And however, which again signals that in African countries, the looking after someone that just lost a spouse should be taken place not only on the first year, but in the second year after. Now, another research that interests me, and I work with some of my previous PhD students that now are academics on their own, is related to car insurance. The car insurance in a particular situation. I don't know how many of you know, but women in Saudi Arabia were not allowed to drive until the 24th of June, 2018. So 2 years ago, the ban on women driving a car has been lifted. So all of a sudden, the whole country of Saudi Arabia will have as drivers, not only men, but women. So this simple policy change has a huge effect in many aspects. One of them being insurance. How will you price a woman driver, a woman that has never driven before, that starts driving lessons in her 40s, for instance, and has no experience of driving in her life? And just to signal what kind of changes you see from such a policy change, one of the first ones is, as you see in this picture taken from CNN, women are happy that they do not need a driver. They don't need to call a driver. So all of a sudden, the jobs of these men that were just meant to drive women around has to be replaced by jobs of driving schools, someone to teach women to drive. And the fact that all of a sudden in traffic will be women drivers, the men driving around will also be affected by encountering on the other car a woman driver. And all of this will have an impact on how the behavior of drivers in traffic will evolve. Now, as you see here, the short-term impact, apart from driving lessons and driving schools, and of course more car will be sold and or leased, is the car insurance. And the biggest question is, how will you price? How much will you charge a woman that wants to drive? And how do you make sure that they are correctly priced? And for that reason, we are trying to propose a system that it's already available in many other countries. It's referred to as the bonus-malus system or a reward penalty system, where you look at the history of a driver and depending on how they drove in the past, you reward them or you penalize them. Of course, these women will have no history to begin with, so they will start at the basis premium or a basis tariff. But then as time passes, the company will have to make sure to reward them or penalize them based on their behavior. And we suggest the same for men so that the whole market will benefit from this system. Now, the last kind of insurance that I want to refer to is related to property insurance. This will be for houses. And now I'm going to talk about houses in Japan. You might know that Japan is what is called, it's placed on the so-called Pacific Ring of Fire and is most active in terms of earthquakes in the entire world. So Japan has approximately 20% of the earthquakes around the world of magnitude 6 or above. In 1 year, it has 1,500 earthquakes, and nearly every day there is a tremor. And you can see this from any little search online. The graph I show here it's about how long this shows, how long in between two earthquakes. As you could see, they are higher heights in between. So the time in between two earthquakes used to be a bit longer, up to 2011, the March 11, 2011, when was the so-called Great East Japan earthquake. And after that earthquake, one could notice that there are more frequent the time in between. So this earthquakes has shortened, something has moved. And how this affects houses, how this affects property insurance. So at the moment, there is no insurance for earthquake in Japan for whatever reasons. One might being that earthquake, it's still considered an extreme event, which usually means rare, but in this case, it's not anymore given its frequency. The other one being that Japanese do not seem to tend to buy earthquake insurance. However, there are areas recognized as more prone to earthquakes than others. And usually immediately after an earthquake, the price of houses in that area would drop. Now, what happens in Japan is the so-called double debt problem, that when someone takes a loan or mortgage to buy a house, if that house is destroyed by an earthquake, after the earthquake, they still have to pay back the mortgage for the house they don't have anymore, and at the same time take a new mortgage for a new house. So that's why the double debt. So what we are suggesting in a joint work with Jiro Akahori and Yuri Mamura from Japan and Hai Ha Pham from Vietnam is that banks will, when they give out a loan for a mortgage, in the repayment of the loan, they incorporate a very small premium for the case of an earthquake, so that if someone loses their house due to this earthquake, they will not have to pay back the house anymore. So they can just take a new loan for a new house. So I hope these were just 3 simple examples of questions that you can see in actuarial mathematics. Now, the mathematics behind them, could be quite sophisticated, and it's a mixture of data analysis and stochastic modeling, and it evolves the results and the abilities for us to get better and more appropriate solutions it evolves at the same time with the evolution of the theoretical part of mathematics. Now, why I encourage anyone to study mathematics, and here in the picture, these are students from University of Liverpool going from Liverpool to London to present some of their results from summer projects. I think you have the opportunity to learn a lot, to make friends, as I said, to question what's happening around you and in the world. You can always find creative solutions to current problems, and you will be able to ignore the boundaries of societies and countries and just be a citizen of the world. Here is my email address. If you have any questions that you cannot ask me right now, I will be happy to answer them. Thank you.
Thank you so much, Dr. Constantinescu. If you have any questions, just drop them in the chat. If you're watching on YouTube, you can put your questions in there too. I am looking right now, so ask away.
Before I fall asleep.
Yeah. I have a question for you. Did you ever consider like pursuing any other subject besides math?
Oh, well, yes. My parents wanted me to be a medical doctor. So I was actually very fond of chemistry at the time. But nevertheless, mathematics was, or solving math problems was what really attracted me and made me relax. So I would take a break from preparing for the medical school by solving math problems. So it was a day when I thought, oh, well, maybe I should pursue mathematics and don't force myself anymore.
Awesome.
I have a question. So what would you recommend like high schoolers who want to pursue mathematics, or what should they start doing so that they have the best way to go through their education, and like what could be something that can guide them through, at least in high school? What should they be doing?
I think they should just try to solve problems, any math problems they can encounter. And as I said, try to solve problems with some of their colleagues and friends and challenge each other and go to any competitions available. I think once you start to, there is a moment, you can be born with that passion, but there is a moment where you become very passionate about getting the right solution or solving a problem differently. And I think that's when you became a mathematician, when you think, oh, can I do it differently or in a simpler way? So probably that would be the advice. Don't be happy with the first solution you found to a problem. Don't be happy that you just did your homework. Try to do it differently. And again, try to compete with your colleagues. I think you learn more from your peers than from any class, any teacher, and any course. Well, I'm a living proof of that.
We actually still have 10 minutes, so
Oh,
yes. Don't feel shy.
I was trying not to include any of the modules to stick to the stories. Is anyone in the audience that likes mathematics or wants to become a mathematician? You can react with your...
I have another question. So, like in mathematics, let's say you are going into in university, you're majoring in math, right? What are the different um things you can do with it? Like I know like you can go into finance, you can go into like where do you think is can these skills be used in the different fields that are there, or like what can a mathematician actually do after college exactly, right? Kind of can you elaborate a little bit on that?
What kind of professions you can have as a mathematician? That's the
Yeah.
question.
Yeah,
Okay.
like yeah, that's kind
Apart
of the
from a
question. Yeah.
ballerina, I think anything. So I think mathematics prepares you for a multitude of jobs. Now, of course, you can stay in education in academia or high school. You can become a teacher, which is always very rewarding. You can be an actuary, as I mentioned. So you can work in any institution that has to deal with risk and any institution that has to deal with data, which is basically almost everything nowadays. Um, and from my experience working with students, our students are very thought out because mathematics gives you a structured way of thinking, and it helps you pose the right questions, the correct question in a situation, even if you don't have a solution, a perfect solution. Having the right question is already a huge plus. And so yeah, I cannot speak highly enough for mathematics. Of course, if you feel passionate about physics, chemistry, everything that is more experimental, even for those subjects, you still need mathematics. You won't have to go into learning new theories and writing new theories, but you'll still have to have a sound mathematical background. Even as a medical doctor, you have to know how much you should give, what is the dosage of in a certain, uh, it's not, I think mathematics is actually beautiful. So it's and not difficult. It's I have a comment on the chat that Einstein didn't get far without differential geometry from his friends. Different times. Yes, I think you have to aspire very high when it comes to, regardless what you want to do. I like to see, and that's the reason I chose the examples and the stories I chose. We have other projects, but these are having societal implications, something that you observe in different societies, in different countries, and you begin to wonder if you can make any change, make any difference in this, and you can, but it's a matter of aspiration and courage to ask the questions, and you can do it. There is no limit.
Okay, well then I have another question.
Thank you.
Is there is there a like when you were studying mathematics, is there someone you looked up to, or was there, how did professors like help you? How did you kind of, yeah, who did you look up to as a mathematician?
So I looked up to my peers always. And again, I will repeat, it's not the same for everyone. I never had a big name mathematician as my role model. My role models were in my immediate reach, were my friends. I was always fascinated that they could solve a problem faster, or how they thought. And this helped me a lot. Now, not to say that were a lot of professors and teachers in my life that helped me become a mathematician. You know the expression that it takes a village to raise a child. I think it takes a village to to raise a mathematician. I'm sure there are mathematicians that are independent thinker and that they can do everything themselves. I'm not one of them. I learn best with others and from others, and sharing what I understand with others. So saying all that, I have to give all the credit to our high school and primary school teachers. So I'm originally from Romania, and we have like a math club where people would volunteer to teach us and solve exceptional problems. So, and they were doing this in their spare time. And I don't think we can ever repay them for that, either by being successful, but what they did is fantastic, and it's hard to replicate. But by doing that, they also encourage us to challenge each other. So they brought us together and gave us a problem, and we had to solve them, and that's how everything started. And I think this model, I cannot advocate enough for such a model to be developed in other places and other countries.
Oh, someone just asked, how long did it take to get your PhD?
Oh, yes. So I did my master and PhD at Oregon State, and both of them took 6 years. So together. So the first, I got my master's after 3 years and PhD after 3. Because it's the first 2 years are usually of grad school are a lot of classes. What made me choose, someone asked me what made me choose actuarial mathematics. I think what made me choose actuarial mathematics was the fact that the problems were concrete, were problems from the real world. I love mathematics. I'm sure you'll hear in the next talks about algebra and combinatorics and probability. So what they call sometimes pure mathematics, the blue sky mathematics, where you solve a problem, a beautiful mathematical problem that you do not know immediately if it will have an application. Where I think in actuarial mathematics, you go the other way. You have a real question and you try to formalize it mathematically. And then the answer may solve a real problem. So that made me choose it. Okay, so I have a question now. You have experience learning math in Europe and US. What do you see how we can view and learn math differently in US compared with the rest of the world and Europe? Okay, so I've been, it's a very difficult question, complex question. So even within Europe, it's not the same. It's not taught the same. It's not approached the same. So for instance, Eastern Europe versus France, Germany, UK, Italy, every country has a very different approach to mathematics. So what I have seen as being successful is if you start very early. If you do mathematics and not shyly, not just a little bit, if you have the courage to study mathematics early on, take that advanced calculus class early on. Do not wait until college. These people will succeed. And this in other countries is compulsory. So what I've seen differently when I went from Romania to US was how more equipped I was from my high school and undergraduate studies theoretically, in terms of theoretical mathematics, than students coming from other backgrounds. And this was just because the syllabus on these countries was different. Of course, if you are talented and dedicated, you can overcome this difference, but it's easier if it's fed to you early on and you challenge yourself early on.
Thank you so much. So does anyone have any last questions before we move on? Okay, yeah. So
Thank you
again,
so much, Dr.
Yeah,
Constantinescu.
thank you for your time.